You are all welcome in this video. In the previous video, we learned to find the area of a polygon. Today in this video, we will see examples based on this. Can you find the area of colored figures shown? Let's start with the first figure. This is a polygon, whose area can be found by the method we learned in the previous video. If we connect these points of this shape in a straight line, you can see that we get three triangles, which we can classify as triangle 1, triangle 2, triangle 3. Can you tell the formula for the area of a triangle? Well done. The formula for the area of a triangle is 1 by 2 times the base times the height. Do we know the height and base measurement of triangle 1? From the information given in the question, we know that the distance between 2 points is 1 inch, from which we can say that the height of triangle 1 is 1 inch and length of base is 2 inches. So with the help of which we find the area of triangle 1, which is 1 square inch. Similarly, we find the height of the triangle 2 and 3 and the length of the base, and then their area can be determined. As a result, after the sum of areas, we get the area of first figure, which is 5 square inches. Let us now look at the second shape. So now in this case, how will we find the area of this shape? We can see that this green shape is surrounded by a square. In addition to this green shape, we see these three triangles, whom we respectively name triangle 3, triangle 4, triangle 5, whose length and height we can easily measure. This is how you can find their area. And then, by subtracting the sum of the areas of the three triangles from the total area of the square, we get the area of the green figure. So can you tell what will be the area of the square? Perfect. Since the length of each side of the square is 4 inches, the area of the square will be 16 square inches. With the help of which we get 8 square inches of green area. Today in this video, we saw examples based on the area of polygons. Welcome all of you to this video. In the previous video, we learned to find the area of rhombus. Going forward, today we will learn to find the area of a polygon. A teacher asks this question in class. A tile looks something like this. Can you find its area? The visible figure is a heptagon because the figure has 7 sides. Let's first name the tiles as A, B, C, D, E, F and G. A student of the class, Sonu, solved this question in this way. He made the diagonals of this heptagon from the vertex A, and by doing so, he got 5 triangles. He thinks that why not take the sum of the area of all these triangles, which will be equal to the area of heptagon. Let's say that the measurements of these 7 triangles are as follows. According to which, by calculating something like this, he finds the area of heptagon, which is 30.5 square centimeter. Another student of the class, Seema, solves this question in this way. Seema thinks that the vertex G must be connected to vertices D and C. So we get one triangle and 2 trapeziums. Suppose its measurements are as follows. With the help of which, by adding the sum of areas, we get the area of the heptagon as 30.5. You can see here that the area of the heptagon is the same in both cases. Thus, by dividing the polygon into its parts, whose formula for the area is known, one can get the area of the entire polygon. Here we discussed 2 situations, and the area of polygon will be equal in both the cases. Similarly, can you find the area of a pentagon or hexagon? Think. Perfect. The pentagon is thus divided into 3 triangles, or its area can be found by dividing it into a triangle and a quadrilateral. And the hexagon is thus divided into 4 triangles, or one can find its area by dividing it into 2 triangles and a quadrilateral. You can also divide the hexagon in another position and find its area. Today in this video, we learned to find the area of a polygon. In the next video, we will see an example based on this.